Hi everyone. In this presentation, we're going to walk through a Python script that uses TensorFlow and Keras to build an image classification model. So the purpose of the script is to demonstrate how to train a simple image classifier and evaluate its performance and use it for making predictions on new images. Okay, so let's get started. So in the first section, we are importing the necessary libraries and modules for the project. We're using matplotlib.py for plotting, TensorFlow and Keras for building, and training the model, Python imaging library for image handling. So we've also imported specific components like ImageDataGenerator and sequential and other layers from Keras that are essential for the different parts of this project. So in this next part, we're going to define some variables, paths that are going to be used throughout the script, and we're going to specify the main data directory, separate directories for training and validation data, and an image path for a new image that we are going to use for prediction. Also, we're going to set the number of classes to 2, and in this case, it's going to be malignant and benign, and the target size for the input images. So we are going to be defining the data generator using ImageDataGenerator, and it's going to help us pre-process and augment the training data. And we're going to apply various transformations, rescaling, rotation, shifting, shearing, zooming, flipping. And this is all to create like a more diverse data set. And they're going to enhance the model's ability to generalize. So now next, we're going to load and pre-process the training and the validation data using the data generator, and we're going to use flow from directory to load images from their respective directories, apply the pre-processing steps, generate batches of data that can be fed directly into the model during training and validation. Now on to building the model architecture. So here we're going to define the architecture of our image classification model, and we're going to be using a sequential model and stacking several layers. The conv2d is going to be the 2D convolutional layer, and it's going to be followed by a max pooling 2D. So that's another layer, and the flattened layer prepares the data for the fully connected layers, so depths. The last layer is going to use the softmax activation function, and it's going to output, the class probabilities. Now we're going to compile the model. In this part, again, we are specifying the optimizer. So Adam. And also the loss function. So categorical cross entropy. And we're also going to choose accuracy as the metric to monitor during training. So now we're going to train the model. We're going to specify the number of training epochs and use the fit function to train the model by using the data generators for training and validation, and it's going to learn to classify the images based on the provided data set. So here I chose to train it on 30 epochs. So when we are evaluating the model, we're going to evaluate its performance using the validation data and the evaluate function. It's going to calculate the loss and accuracy of the model on the validation set. And we're going to print out these metrics and understand how well our model is performing. So saving and loading the model. So we're going to save the model in a file called image classification model h5. And using the save method, and it's going to allow us to reuse the trained model without retraining it. So we're also going to show how to load the model using the load model function. in this next part, oops. So now in this next part, we're going to define a function called preprocess new image to preprocess it before making a prediction. And we're going to load an image. We're going to resize it to match the target size, normalize the pixel values, and expand the dimensions to match the model's input shape. So we're going to use the loaded model to predict the class probabilities of the new image. And here we are going to display the predictions. So finally, the predicted class probabilities and the class names are going to be displayed here for the new image. And these are going to be the class names. They're going to be malignant and benign. And they're going to provide insights into what the model thinks about the content of the new image. So we're going to print the predictions. And now let's run the code and see what it does. Here is the output. It's going to give us insight into how the model is performing, what's happening. It's going to start by telling us that it's found 14 images belonging to 2 classes, 12 validation images also from 2 classes. That's the data set it's going to learn from. And we're going to see some messages from TensorFlow, optimizing itself to use specific CPU instructions for better performance. There's a memory allocation meaning that it's using more memory than it should. And then the script is going to go through 30 training epochs. So we are going to wait for that. So basically an epoch is like a complete pass through a data set. So for each epoch, the script is showing us what's, so it's going to tell us about loss or how far off our predictions are from like the actual values, and accuracy. So how often like our predictions are going to be correct. And this is going to help us track how well our model is kind of learning over time. So now you can see that the model is improving with the accuracy going up and the loss coming down, and that is what I wanted. And apologize, it's kind of slow. It's going to be increasing. Basically, accuracy is going up and loss is going down. I have run this several times and this so I apologize. Mm-hmm. Mm-hmm. Nice. All right, so after the box is gonna evaluate the model using the validation data. And this wasn't seen during training. This is to test how well the model is gonna, it generalizes to new, like unseen images. So basically the final like validation loss and accuracy is giving us a sense of how well our model is likely to perform like on real world data. So saving and loading our model, the script is going to save our trained model to a file named image classification model H5, and there's a warning. Because of that, suggesting using native Keras for better compatibility. And now it's going to process a new image using a trained model to predict this class. So that's basically like asking the model to make an educated guess about like what's there. And then it is going to predict. Yay. So the script is going to tell us that the model is actually pretty confident that the image belongs to the benign class. So it's giving us a probability score for this. And well, the closer the scores to 1, you know, the more confident. But yeah, it's pretty good. So basically, here you have it. Here is the output. We've seen training, evaluation, and saving the model. And it made a real prediction, and it's basically going to help us refine our model and trust its predictions more confidently. And thank you so much for your time, and have a great day, guys.